think you can hear me. Maybe a little quiet. If you're watching the stream not live, make sure and check the description for time codes. We're not going to get going for another 5 minutes or so. And then we'll have time codes into like all the different stuff we're going to talk about today. It's going to be a nice long stream. There goes the cat. She doesn't like it when I talk, so I'll have to let her out. But yeah, if you're just new to this, make sure and check out the time codes. There's no reason to, well, you can certainly hang out. But yeah, if you want to find something in particular, that's a great way to do it. Okay, let me cat. I'll say hellos after I let the cat out here. You just don't like me talking, huh? Go ahead. Go. I know. Part of me thinks she'll get used to me doing it, and like I don't want to kick her out of bed. Who let the cats out? All right, hello to Alvaro. Hello, Microdev. Hello, Bruce. Hello, Unexpected Maker. Twitch is up. Thank you, DCD. And DCD is the person I think who does all the time codes. I try to be good about it, but these last few weeks have been super busy. So thank you to DCD for doing that. Hello, Gary. Hi, Frank. How's it going? It's going good. Yeah, I feel like I'm still in the audio weeds, but I'm moving past them. I don't feel lost in the weeds anymore, which is good. And swapped, I got my new computer parts, so it's currently, OBS is running at 0.5% of my CPU. So that's pretty awesome. And the USB seems to be okay. So fingers crossed the USB is okay. Hi, Folknology. Hi, Alvaro. Fede2. To warm up, and yeah, I said hi to Frank. I think everything's paused. Everything's going. We're live on Twitch. I remembered everything. I think. We might have a guest. We'll see. YouTube says no data. Excellent connection. Okay. Yeah, so we'll get started in a few minutes, but we'll answer Alvaro's question. It says, are the S2 chips that Unexpected Maker showed the ones that LadyAda has been waiting for? I didn't watch that stream, but I believe so. I know that he was trying to get CircuitPython going on that. We'll see. We'll see about the guest. There's no promises, but I got some interest. But yeah, the ESP32S2 chips that have built-in flash and RAM are very, very interesting, especially for small boards. And I know the tiny S2, I think, covers that. Hi, Love the Factory. Hi, Anecdata. Hi, David. I forgot to say hi to David. Sorry about objectifying everyone. If somebody has a tip for a better way to show Discord on the stream, I'm open to it. I keep hoping that they'll fix this, but it doesn't seem to be the case. Unexpected Maker says, I think LadyAdy is waiting for the modules, not just the chips. Yeah, I believe that. I think generally she prefers to use the modules because they're pre-certified, which makes it easier to certify the whole thing. How are we doing? How's I guess we're about to get going, but I want to hear how folks are liking the RP2040 and the Pico. I like to talk about it. I think it's a neat chip, and it's so like early days still. I got my SuperCon shirt from last year on. Hi, Johnny. Good evening. It's not my morning routines. Yeah, it's Unexpected Maker's morning. I'm listening to you via Unexpected Maker's computer. Weird. How is that? Hi, Mark. David G says, can the Pico do .star with PIO? You could, but there's no reason to. You could do .star with SPI just fine. And that's what it uses by default. Bruce says, will Raspberry Pi be allocating PIDs for people using the RP2040? I have no idea, and that's probably something we should ask them about. Get ahead of that. I'm fully USB PID immersed. Yeah, totally. Yeah. JF Abernathy says, Pico is fun except for the SD card that you already know about. Yeah, it needs to be fixed. The SD card library code just makes them cheats a bit getting stuff back from the SPI device that it really shouldn't. So instead of adding it all to the native SPI device, we just need to make it remember it for itself. DCD says, I'm continuing to think of new applications for the RP2040. Gamma Game says, I haven't had a lot of time this week waiting for my 3D printer, but I'm really liking it. CircuitPython is great. Oh, thanks. I'm glad you like it. That's been my top line message, is just like, try it, see what you think. David says, did you do the final review of CircuitPython 2021? I don't think so. That's on my to-do list. I feel like I need to get through this audio stuff. There's just like so many things that people are asking for the RP2040 that it's tough. But yeah, keep bugging me about it. I think I've posted everyone's post. So if you've emailed me and I haven't posted it, let me know. But I think I'm caught up at least. I just haven't done the like final post that has all the links and says it's done. Hi, Davey from Colorado. Is it Ryan? Did I say that right? From Denver? Or is there different emphasis? All right. Well, it's just after. Yes. Great. I got it right. West Coast of Canada. Yep. Bruce is north of Vancouver by Whistler. Lucky duck. I think by Whistler. JF Abernathy says, doing Pico C and C++ development on VS Code with SWD debug makes you appreciate CircuitPython. Yes. I tried to encourage somebody to try it, and they were like, I hate Python. And I'm like, I can't help you. But they also said they hadn't tried it, so I was like, if that's the way you feel about it, then that's the way you feel about it. But you're missing out. Okay, let's do housekeeping. And I think, yeah. Take a time code. Hello, everybody. My name is Scott, and I go by Tan Newt online. I work for Adafruit on CircuitPython. Adafruit is an open source hardware and software company based in New York that does electronics for folks. Hello, Andrew Reed. Thanks for popping up in the chat. They've been around about 15 years, founded by a woman, Lamore Freed. And they do open source hardware and electronics. They try to teach you how to use them and build the things that you want to build. CircuitPython is an effort by them to make Python really easy and accessible on these little tiny computers called microcontrollers. I've got some, that's not one. I got some on my desk. Here's an example. It's called a Cutie Pie. Let me switch to a Cutie Pie there. So that's an example of one board. The little black chip there is the microcontroller. It's like a full computer all in one. I will also, let me show this. I wanted to have this. So there's a Raspberry Pi Pico. I'll put it right side up. This is probably what we're going to talk about most today. It's a new microcontroller from the Raspberry Pi Foundation. And it runs CircuitPython on it, making it really easy to program to do what you want. So yeah, they pay me to bring CircuitPython to new platforms. Adafruit makes its money by selling hardware to folks and teaching them how to use it. So if you want to support me, you can support Adafruit by going to adafruit.com. They pay me to stream, and they pay me to work on CircuitPython. So thanks to them. If you'd like to join me and a bunch of others chatting on the Discord, it's a chat that doesn't go away when the stream ends. You can go to adafru.it/discord. That'll drop you in. We're in the live broadcast chat channel. That's a mouthful. Today, but most of CircuitPython's development is in the CircuitPython channel there. If you're new to CircuitPython, there is also a help with CircuitPython that can help you get the basics going. So this is a deep dive. It happens every week. I think I skipped, 1 or 2 weeks just for the holidays, but generally every week on Friday. Let me switch back to eye tracking mode. It happens normally at 2 p.m. Pacific. I live in Seattle, so it's Pacific time zone. That is I won't convert the times. I don't know the times. Occasionally I do it on Thursdays, a day early, if I want to have Fridays off. So be aware of that. It typically goes for 2 hours or more. So there's going to be a lot of content, and I take questions. So as questions come up, we'll discuss those. Some of them can be longer answers, but it is a deep dive. And the goal is for me to like kind of brain dump and try to explain the best I can all the topics that come up. And I'll of course say I don't know when I don't know. So questions are welcome. Go ahead and prepare that. I've also got the work that I've been working on this week that I want to show off, but that's kind of second to questions. Next week is on Friday, so be aware of that. And then just the last bit of housekeeping is that the cat that you see here, his name is Spook. I'll even go to cat cam. He just loves to sleep in the window. He is epileptic though, so beware that he does have seizures from time to time. He's actually been really good, so he hasn't had them recently. But I do like to say that if I'm on the stream and not like talking or anything, it's because I'm just making sure that he's all right. And then I'll come back to that. So I think that's all the housekeeping. So if you have questions, now's the time to ask them. I think there have been a couple, so I'll go through there. I'll also say hi to folks, and then I'll show you the stuff that I've been working on if we run out of questions. There is a chance I might have a guest drop in later. We'll see. But yeah, we will see. No promises. Okay. And DCD, thank you to DCD for doing time codes and notes. I really appreciate it. Okay, so we talked about that. In plus or minus 10 hours, FOSDEM 2021 is starting. It's virtual, so I guess everybody should take a look at that. Hello to Matt. Hello to M4TK. Hello to David from Wisconsin. My mom's from Wisconsin. My wife's from Michigan. Hey, Charles, 40s in Southeast Pennsylvania. That sounds reasonable. That's about what it is here. And dry. Yeah, Neurodoc says, yeah, somebody didn't like being suggested to try CircuitPython. Well, it's their loss. Hi, Ken from South Dakota. I think brisk is probably an understatement to say how the weather is there. Yeah, the person who wasn't too pleased, I think, was actually on the Discord, but everybody was really nice in their response, so that was great. Bruce S says, oh, that reminds me, can we get a tiny UF2 channel? I don't think there is an easy way for people to find stuff about it, but maybe nobody wants to know. And Microdev says +1 2. Can I create a channel? Sure, create channel. Tiny UF2. Done. All right, now there's a tiny UF2 channel. It's at the bottom, but I made it for you. We could connect it up to the repo later. Hi, Fred from Pittsburgh suburbs. Let's see. Nice. Neurodoc is thanking Bruce S for working on the LilyGo build, which I think we finally got in, right? And also did the tiny UF2 stuff for that. David G asks, did you get a chance to play with the Dazzle Gameduino X3? I didn't. I have something that I haven't tried yet. But no, I haven't had a chance to play with that. Hi, Hugo. I haven't, no. I think David DCD, who's taking notes, wants me to talk about this, so let's talk about this. Let me switch to the desktop. So there was exciting news from the world of FPGAs. William D. Jones has added Mach X02 family support to the open tool chains, which is really exciting. And in fact, I have a board that I designed a while ago now. It's covered in cat hair, so excuse the cat hair. But this board that I designed based on the tiny AX series, tiny FPGA AX series, it's a Stema it's a Stema board, but it has an FPGA on it. And the goal is that you would use it like an I2C device, but it's an FPGA. So you could load whatever you wanted onto it. David G says, the one who takes the notes decides on the topic. Okay, next up. Yeah, so this is super exciting. I'll get to it at some point. I have no idea when. Gamma Games says, is UART planned for CircuitPython for the Pico? Yes, definitely. I was thinking about doing it, and then I had a discussion with Lamore about whether I should do audio first or whatever, and we decided audio would be a better thing to do. So Microdev was actually going to take a look at UART, so I don't know how far they've gotten. But yeah, we'll definitely do UART, and it's come up a number of times, so it's going to be pretty high on my list. But my brain is all in audio land right now, and I don't want to leave it before I'm kind of like finished with it. So yeah, and Fede2 Alvaro said, I showed it to the free software FPGA people on Twitter and they loved it, the board design. Yeah. Stuck with NVM, currently looking into UART. Yep. Frank says, yeah, UART is what you mentioned I needed for my stepper motor project. Yeah, I think, Frank, you had a controller chip that had TX and RX on it, and so you would talk to it with over UART. Usually motors and steppers that we do are just PWM, but I think the one that you had was a UART one. Hugo says, Hams Lab says, Audio Land is a good place to be. It's a daunting place to get into, though. It's been like 3+ years since I looked at it last, so my brain is, I think, I've gotten my hands around most of it, so that's pretty good. So Hugo, yeah, Bad Abby, I see your question also. Let me add that to the notes for later, but I want to address Hugo's question because, I'm excited about it. Hugo asks, is the new computer built yet? Time for a tour to hardware. Yes, this is all running on the new system. So it's kind of a hybrid of my old one. So I reused the NVMe drive that I reused the case and the power supply. So if you want details, I got an AMD Ryzen 9 5950X, which I was very excited about. It's a 16 core, 32 thread. And it's pretty quick. Let's just show something here that I was doing. So I just, most of the time I make CircuitPython. So I'll just show you the compile time here. We can use time to do it. So this is a clean build of the Feather RP2040, and it was just over 5 seconds for the whole build from start to finish. And I actually suspect that a lot of that time is like our Q string stuff. So I'm very pleased with it. I've also noticed like all my browser windows pop in a lot more quickly. I also upgraded the RAM because my RAM was older and slower. So I got 32 gigs of just like actually the older Crucial Ballistics. So it's running at DDR 3600, which I think is about like 50% faster than what I was clocking my older RAM at. So I'm very pleased with it. And so far the other thing was like getting better USB in and out of the computer. So the motherboard, I got the Crosshair Hero 8 with Wi-Fi, which I think somebody mentioned like when I was talking about this, that was the board that I would end up with. And I looked at that, and one of the things that was interesting to me about that motherboard was that it broke out all of the USB from the CPU chip. Crosshair's the cat version, Crossfire. Yeah, what is it? I thought it was Crosshair. Yeah, it's Crosshair. But yeah, this is, I found this really awesome spreadsheet of all of the AM4, which is the like socket for the CPU. I found a really awesome spreadsheet that like lays out how everything is connected on the motherboard. And so this ASUS, the one right below it, was also the case where it actually broke out all of the like really high speed USB to the back. So yeah, I'm very happy with it. So it's been great. And like I said, like when I used to stream, the CPU on OBS would be like 3%, and now it's 0.6%. The graphics card I have is like the low end of the AMD graphics cards. But it can do PCIe 4, and so the old motherboard I think only had PCIe 2 or 3 depending to the graphics card. So I should also just like, even though it's the same graphics card, I should get more bandwidth to and from it, which would be really cool. And I did have to build, I did have to do this build on the Raspberry Pi. I used Raspberry Pi if I need to SWD debug it, and it took like minutes to do the same build. So I'm pretty happy with it. Okay. Let's go back to Bad Abby's question. I answered Bruce S.'s question, which was how fast it was to build. David G says, there's another game where you ask an interesting question and see if Scott jumps into it. And Hamslab says, hit me up if you have any questions. Audio is what I do all the time in my job. Yeah, you'll probably find that my audio game is like not very good. But thank you for the offer. Definitely. I'll show you what we've got going, and I'm sure there's, like most things that I do and most things we do in CircuitPython, there's always room for improvement. Okay, let's talk sleep. That Bad Abby's asking about. So Bad Abby said, I tried looking at sleep on the NRF. Can you explain the ESP32S2 code and where the calls would differ? Also, where do the NRF specific libraries live? Don't show us, make us listen to it. Yeah, that's true. How many GPIO pins does the motherboard have? None, I don't think. I thought about trying to get one with a COM part. Yeah, Crossfire is how you run multiple AMD GPUs in one system. Thank you, Pikachu. Another thing I wanted in a motherboard is so usually a CPU has 16 PCIe lanes to the graphics card slot, and I wanted to make sure that it was actually split where it was 8 there and 8 to another slot. Because I don't need the top end graphics card. So I'd rather spend 8 there and then have another option for something else. Is there a place on that motherboard that can run CircuitPython? Probably. I haven't looked into it. Okay, sorry, I got distracted. All right, let's dig. So there's kind of two pieces to sleep. There's the alarm API, and that's the thing that gets you into deep sleep. So like everything, you go into ports, and then you pick your port, and then common HAL alarm. So there's going to be a lot of here, especially 8 PCIe lanes to the external COM port. The reason I wanted it is there's a USB host controller card that I might actually want it, but the USB's been good so far. But that frees me up to putting something else there. Okay, so if we look in here, we can see alarm reset. So this does all the reset stuff. We have the thing of like telling you how you woke up. Detecting whether you woke up from sleep. Yeah, so this is definitely a place to look and mimic. And then there's light sleep until alarms, which is the, like, you don't actually do anything different. If you can idle the core, that's good. But it's like as light as you can. And then you return the alarm that woke you up. So that's the probably the easier case. And it says finally C source code. Sorry, I was chatting too long. But yeah, CircuitPython is all C under the hood. So if you prefer C, we'd love to have more core contributors. And then there's also there's 2 stages to deep sleep. There's an API from Python that is exit to deep sleep, but what it does is it actually internally calls this set deep sleep alarms, and then it raises an exception that gets all the way to the outer stages, and then that shuts the VM down and resets everything, and then calls this alarm enter deep sleep. So the like deep sleep process is like two phase. So that's a place to look. The other thing to look at is the NRF datasheet. So, and Bad Abby, if you have more things you wanna talk about or more questions, let me know. Yeah, that's good. We should talk about that too. Oh, I want to talk about... Yeah, I have a couple things I want to talk about. Hi, Robot Meister. Hi, Phil. Yeah, there's OLPC. Okay, I didn't miss anything. I see Phil. Phil, I'll get your... I want to talk about that, so don't let me forget. But let's keep going here first. Oh, and I don't want that. Did I autocomplete the wrong thing? I basically got as far as copying the code from the ESP32S2. Yeah, so I think the first thing that I have to think, that I generally think about is, like, what do I think I can actually do? Yeah, we are using the HAL libraries. It's been a while since I worked on NRF, honestly. But the first thing I like to look at is just what it can actually do. So there's system off mode. So the thing that we try to distinguish in CircuitPython is like light sleep, you preserve the VM, so all the memory in the state of the code, and then deep sleep, you don't. So that's the main difference there. And so system off. I prefer SimSys. Yeah, SimSys is pretty nice. There's a few SimSys things I missed with RP2040. I wish they had like the NVIC stuff. Current consumption. Let's see. So this is an interesting thing of like trying to figure out what your target is. I'll scooch it over. So this is what they say you can do. So system on full RAM retention is 2.3 microamps. And that's like really good. Like most of our sleep states don't get that far down. 17 microamps for waking on an input event. Wake on RTC. So that's the place I would start, is this wake on RTC. That's kind of oh, I guess that's RAM retention. No RAM retention, wake on RTC is 1.5 microamps. Like it's all like impressive. Like Alex Whittemore was doing some stuff, and he noticed a huge power drop just in the way that we do the sleep in NRF currently. So just when you do time.sleep, it actually there's a ARM instruction called wait for interrupt, which is WFI. And so if we go into, actually, so the other place you have to know about, I think, is in ports. All the ports have this, but I'll show you the NRF version. Is in port, there is, oh, I hit the LED key. Why is my keyboard flashing? There's interrupt after ticks. So this is used for time.sleep that says, oh, like set this real-time clock alarm further out that will wake me up. And then that gets set, some other code happens, and then this port idle until interrupt is called. So it does some floating point stuff to make sure it can sleep, and then it changes which call it does to based on whether Bluetooth is enabled or not. So if Bluetooth is not enabled, we call WFI, which is wait for interrupt. So what that does is it like stops the CPU clock. It stays powered, so all the registers stay there, but the clock itself is fixed, and so that saves power. And then what happens is whenever an interrupt comes in, and I think generally even if it doesn't actually cause an interrupt handler, and in fact you can see we disable interrupts around that. So when interrupts are off, an interrupt will still resume from a wait for interrupt. So that's there. So the question, I think, the other end of that is, how do you figure out what APIs to use? So you can see here, here's a soft device API. You probably don't need it. The other thing to look at is this NRFX, which I think is on GitHub. So if we look at that, I haven't done this. It might be lower level. Yeah, but here's NRF power like you're talking about. So I suspect this is what you want. Activating a power task. This might be lower level than you need. Sorry, the real answer is I don't know. I haven't looked at it. LTE modem domain. So here's an example. Here's NRF power system off. And it says the only way to wake up is by reset. So you wouldn't want that. You would want to find the one that turns the system off but can wake up based on the things that the alarms that you have set. Badavi says, all good. I think I'm on the right track. All right. Well, I hope that helped. It's one of, sometimes it's just like, I haven't looked at it yet, so I don't have that much context. But yeah, it sounds like you're on the right track. Which is actually the goal for me, right? Like, it's better for me to get people on the right track. Oh, the map behind me. This map? So I used to work on Google Maps. So I would decorate a lot of stuff on maps. And I can take it off the wall if you really want to see it. But it's a National Geographic world map. I think my dad got it for me. Yeah, I can show it. I think my wife put it up there. She moved it out of the living room. That gives you a great view of my light. Ooh, this is an easy one. Is eye tracking enabled? Yes, it is. I like it old style. Yeah, I like it too. I like maps. You know, my wife works on Google Maps now. Full circle. The Code Gamers asks, what language is your favorite to code in? My favorite to code in is Python because it's really fast and easy to get started. I end up writing a lot of C code, but I prefer Python. Okay, let's talk about satellites. So Phil talked about this a little bit, and I saw it on the blog, so let me pull up the blog. Switch to the desktop again. This thing is cool. Lamore found this. Somebody has created a UF2 that runs in the execute in place RAM on the RP2040, and it runs as a debugger. So you can run code in your normal spot and then put this there instead. It'll just be slow because it will run from Flash. So that's cool and like super fresh on the blog. But the satellite stuff. Oh yeah, this is, I also wanted to talk about this. So much good stuff. If you're not subscribed to the Adafruit blog, I recommend it. It does, I do get weirded out when I'm like looking through it and I see posts that I do. Where did Max's post go? Spinach that can send email. Maybe I should search for it. It was recent though. I just read it. So there's 3 satellites that run CircuitPython that they launched into space. Here we go. And I know FedA2 was actually listening to their broadcasts. So these 3 and Max Holiday, I think Holiday, wrote in to like give us some pictures and stuff. Talked about the benefits of it. So it's very, very cool. And they went up in that like a recent launch. Yeah, thank you for the link. I found it as well. So that's pretty wild. I know, Max added some stuff to the code. So if you saw, like, for example, he added support for MRAM. I think it was MRAM, which is like a magnetic flash store. It's not flash, but it acts like flash and it's more resilient to radiation. So there's some stuff there. But yeah, it's pretty cool. Yeah, and Alvaro says, I have a couple of stations listening in. Yeah, you mentioned that they were almost out of battery, and this goes into the fact that they were almost out of battery because they tumbled out of the launch craft and weren't oriented correctly to the sun, I guess. So that's pretty wild to think about. What are you listening in? I've done some before via RTL SDR. I think it's Laura, but I could be wrong. I'm not actually listening to, but we'll see what Alvaro says. Yep, Laura. Okay, that's cool. And yeah, I did see that. This is the thing I wanted to talk about. If you're using a Pico, the Adafruit AR app actually now supports overlaying pins on Pico. So should I try it live? I got it working earlier, and I think I have the overhead here. Hopefully nobody will text me while I'm trying to do it. But so let me see. Aura says, yes, the 3 of them are in sleep mode right now because of the low battery. At least they're not dead yet. So here's Pico. Unlock my phone. I think I have it open. So here's Adafruit AR. And there's 3 modes. There's Adabot, board scanner, and QR code. So if I hit board scanner here, it says some info, and of course it's upside down. So board scanner mode, and I hit done, and I already gave it permission. So let's see. That's where you can see it. So I'll move the Pico. We'll see if it can. It had a little trouble earlier. There we go. So I had to tilt it a little bit, but it is live, which is cool. So you can see I can like move the phone, and it manages enough, I think, to do it. And of course, it's what, blurry. Has trouble focusing on it. But it's actually, I think I might actually use this just as a way to make sure that, yeah, sorry, the focus just doesn't know what to do with a phone screen. There we go. That's a good one. But yeah, if it's like down on a breadboard, right, like that's going to be super handy to just make sure that the pins are right. So yeah, thanks to Trevor for doing that. Trevor's one of our iOS folks at Adafruit. So if you think that's cool, the app is free and it is open source. I asked Trevor, but it's just not, he hasn't pushed the latest code, I don't think. It is a little bit finicky, but I've managed to get it to work if you just angle it right. We blew some minds. Unfortunately, it's iOS only. I don't think it does the back, but the back does have pin labels on it, to be fair. But let me try. Let me see. So there's... Sorry, I've got... doesn't look like it. It looks like it's only the top. I think it could do other boards too. This is actually the first time I've used it. Most of our boards are well labeled. I'll show it again. Let's see if you have to get like the angle right. Like not all angles it can get. Of course it can track it better once it finds it once. I don't know exactly how it works. Maybe I should have Trevor on and ask. Gamma Game says, I soldered my Pico upside down so I could see the pins, but this way is easier when you have to upload a new UF2 file. Yeah, so it didn't work from the back, unfortunately. Hugo says, yes, please have him on. Okay, I'll bug him. The other idea I had for a guest was Brent, actually. So Brent does a lot of the IoT libraries and things. Yeah, somebody asked, do I use PyCharm? I don't. I generally don't like IDEs that try to do everything. I find them really intrusive, especially VS Code. VS Code's like constantly popping stuff up, and I don't care. So yeah, if you have iOS and the Pico, try the iOS app. It's called Adafruit AR. Is this an original Salier analyzer? It's not the original. It's a Logic 16, Logic Pro 16, which I think at the time was the top end. I like Logic analyzers are very, very useful. Okay, let's go here. One question was, Keith E says, how does it add boards? Does it work with KiCad files as an input? No, I think what it was is I think I just saw like some discussion about it, but Trevor was saying that I think he was taking the original like photo from the store, and then I think he has control over like what portions of the photo iOS is looking for. So depending on whether he includes the pins or the chip or whatever, like it can change how well it works. So keep an eye out for the repository in that. It's open source. So I wonder if it was in a breadboard if all the wires were going anywhere. Yeah, perfect segue. Let's do that. So I've got a couple things. Actually, no, I wasn't going to do it that way. I wanted to actually see if I could get some audio playing today. But we can test that. Here, I'll just undo my SWD setup and try to like confuse it a bit, and we'll see how well it works. I'm not actually going to press it down. But so here's, I'll do the overhead again. Overhead. So there's another Pico. It's got headers on it. and it's got some wires. And let's just try it some more. Oh, did I lower it down? I don't know what portion of the board it's going for. There we go. So it's definitely got some on it. I know you can't move the Salier in the way. So it's definitely not perfect, but it's nice that like once it finds it, it's pretty solid. Like if you were trying to understand what pin was what, like it's pretty resilient. I mean, I'm pretty impressed. Like that's enough to be able to confirm. Let's try it upside down or sideways too. I don't know. I don't know if the orientation matters. No, the orientation doesn't matter. I don't know exactly what part of the image it's looking for. It'd be cool to kind of like reverse engineer it. I had it. You know, I have pretty good lighting in here as well, because I have the front light on. It's weird that like when it's blurry, it works sometimes. Yeah, not perfect, but it's also like, I think just trained on a single image. Oh, that's interesting. You can see the infrared from the front-facing camera. Briefly. Yeah, I think it's enough to verify. It's not gonna, it doesn't work perfect, but the reason I was asking Trevor if it's open source is like if people wanted to work on it and see if they couldn't tune it to work better. I know Trevor spent some time on it, but there's, you know, always more time and more conditions can train stuff better. Okay, so we're on the overhead, and let's talk audio. Thank you, David, for taking notes. Okay, so what I have here is, well, this is what I've been doing so far. So I have a Salier, and I'll turn it on and I'll show you what I'm doing. So this is the Adafruit Feather. This is one of the very few RP2040 prototypes that we have of the Feather. So the board is designed. We're just waiting to get chips. But I actually use this to develop on, because not only does it have a boot select button, which is this one, and again, the focus is just, I want to see the cat hair on the board. Thank you very much. There we go. That's much better. So yeah, boot select button on the end, along with a Stema port. And then there's a reset button here. So I prefer this over the Pico, because what I can do is I can just hold the boot select and hit reset to get into the UF2 bootloader. It's much easier than having to plug and unplug. So what I've got here is I've got 3 cables. I'm only using actually one of them. Four data cables and a ground to the Salier. And this is how I've been checking to see if my audio stuff works. So let me show you what code I'm using on that. So for those of you new to CircuitPython, and this is a weird case, what it does is it shows up as a drive. So this is Linux KDE. And the reason there's 2 drives is because I actually have 2 CircuitPython boards plugged in. I have this one, but I also have one for doing the time codes that I'm failing at. Hamslab says, is that a 10-pin SWD connector? You betcha. It is, yeah. That's our go-to connector for it. Okay, so I think it's the first one here. So what do we see on here? Oh, this first one has slideshow stuff. So I think it's a clue that's running the timing stuff. So this is the wrong board. So I'm actually gonna just eject it so I don't get distracted. Oh, and I reset it. So I've lost my time codes. Suggest a guest, Trinamic Chips Wizard. I don't know who that is. Okay, so let me show you my audio test code. And it's giant, so I'm going to have to make the window a lot smaller. So here's my code.py. If you've not done audio in CircuitPython before, one of the things that you can do with it is what I'm testing here, which is just looping a single like waveform of a sample. And by changing the frequency of the sample, you can actually change the pitch. So if we get things going, we'll play around with that. Quadrature encoder coprocessor. Yeah, send me some links. Oh yeah, and Zombri in the chat, who also goes by foamyguy, is has more professional Python setups and has been streaming as well. So if you Zombri, if you're streaming tomorrow, let folks know. I think you stream on Saturdays. So, okay, so what do we have here? We have a bunch of imports. So audio core does wave file and sample. Audio PWM IO is the output. Board for pins, digital IO. So I have this trigger pin that I'm just using to synchronize easily the logic capture with when I think the code is running. So that trigger pin is not audio specific. It's just how I'm doing the capture. Array is what I use to store the sample. Time for sleep, and math for doing some sine math. So the first section here is I'm constructing 4 different samples. They're all sine waves at 440 hertz, which is A440, which is like one of the like tuning tones. So I'm saying like I want a sample rate of 8,000. So this is figuring out how many samples it is to get a period of 440. And then I'm generating 4 different samples. I'm doing unsigned 8-bit, signed 8-bit, unsigned 16-bit, and signed 16-bit. And I'm putting those into a list. Okay, foamyguy, aka Zombri, says, I'm streaming tomorrow morning, 10 a.m. Central Time. Thank you. Which I think is 2 hours different from Pacific time. So that would be 8 a.m. Pacific, if that makes more sense. Okay, so we create 4 samples, and then what we're doing is we're looping through them, and I'm printing off what sample I'm playing. I'm setting the trigger line low just to get the logic analyzer to capture it. I'm playing it through the DAC, and this is a case where CircuitPython does something in the background. So you play and you tell it loop, and it will keep playing until you tell it to stop. And it's funny, I named this DAC because I based it on an example that actually has a DAC where this doesn't actually have one. So what I'm doing is I'm looping a sample for 1/10 of a second, stopping, setting the trigger high, and then looping around and doing another sample. So it's a good way to... Let's see. Sorry, I got pinged. So what I can do is, so this is on the drive, and let me open Logic. Oh, okay, I don't need to update. Let me just show you. So I can also get screen going. So here we can see it's running on the RP2040. That's good because it could actually be the other one that I messed up. So what I'm going to do is I'm going to hit start for the capture and then Control D. And you can see that there's a lot more prints here than there are in the code, and that's because I'm doing a bunch of prints from the C level. But if you saw it, there's some stuff that went by here. And so what we have is this yellow line is the trigger pin. Yeah, there's some IDE discussion there that in the YouTube chat if people are curious. I'm not really an IDE person. So what we have here is we have 4 blips of the trigger pin, which makes sense. That's for like the 2 8-bits and the 2 16-bit samples. And then what we can do is we can zoom in here, and this is a PWM audio signal. So if we look here, we can, well, it doesn't really show on the video very well. Sorry, but if we scroll through here, so it's mostly high. And then as we scroll right, we'll see that it gets less and less so. So it's a sine wave, right? So we should see it like peak with almost the full thing and then go down to the bottom. And I think I have a bug here. So if we look here, we have high and then less high, and then it goes high again. So this is, let's see, in the first blob. Yeah, so that's 8-bit unsigned, 8-bit signed, 16-bit. And then we can see what 16-bit is doing here, and that doesn't look right at all. So my code doesn't work. And I forgot that I hadn't fixed it. But I was kind of curious to hear what it sounded like. So even though it doesn't work, because it's like blipping through things, I'm just curious. So I have a speaker here. And let's see, it's playing the audio on the purple. So I think what I can do is oh, you can see the overhead. So some folks are saying that it's they don't like all of the resets that CircuitPython does. So you can turn the auto reload off on CircuitPython. I don't have a problem with it, but if folks do. One thing I do have to do occasionally on Linux here is sometimes I'll do the sync command, and that will just make sure that like everything is synced to the file system. Okay, so what I'm going to do here is I'm going to take out the stuff to monitor. And I'm just going to see if I can't get some weird noises coming out of the speaker that I've got here. So what I have here is it's the Stema Speaker. And I found this when I was looking for an amp, and I was like, oh, this is perfect. So the speaker is here. It's got a built-in amplifier. And then I have a cable that's just the 3 wires. So white is going to be the audio, and then power and ground. So let's try that. And I forgot what I was plugged into. It's going to make some funny noises. We'll see. We'll see. I haven't tried this yet. So it's plugged into D13, which is the 4th pin in. And then we have to power it as well. So let's do ground is 4 in. And then 3 I think is 2 over. It stopped. Did it die? Sometimes when you plug in power, it blips the power and causes it to restart. No, we're still connected to screen. Maybe oh no, it terminated. Yeah, so something went wrong with the chip. So I'll just hit reset. That's interesting. But what can happen is that because there's usually capacitors on an external board, if you plug it in, it sucks a bunch of current and causes the power to dip for a brief moment. It didn't do it enough for the NeoPixel to get confused, though. So I'll just hit the reset button. Did you hear that? Let me pull up the screen and I can make it do it again. I'm going to lift it up above the thing so it's close to the... It's weird. It shouldn't be 2 pitches, right? Like it should be just an A440 tone. But what I'm curious about is if we do... What if we, like the 16 bits are definitely wrong. So let's just comment out the 2 16-bit ones and hit save. Oh, and I haven't mounted it. Woo. Mount it. Okay. Yeah, so that is interesting. So these are this is just the 8 bits. Oh, thank you. I can't manage to do it when am I blipping the power by holding it up, maybe? Like, that sounds pretty good. So that's it sounds like the 8-bit sounds okay. So it's the 16-bit. There's some ugly code that maybe we could look at. Aha, I blipped it again. It's possible that I'm not getting enough power. I wonder if I can do I know it's going to be louder if I do power to USB here. I think it'll be louder. I don't have enough hands. That sounds about right. Actually, let me show you as well. So, each sample has a sample rate here. So what you can cheat to change the pitch by just changing the sample rate. Ah, unmount it again. So now it is A4. Steve says it's A440. Perfect. That's what I'm going for. Now this should be 220 and maybe I should put a pause between them. Takes out the guitar tuner. Whoa. Is it duplicating? I kind of like that. You can hear that still, right? If it's not held up to the mic. Audio is so much fun. It might be playing the 8 bits a second time. Anyway, it's fun. Oh, thank you, Bold. Yeah, so that's one of the 2 ways that I want to add audio support to the RP2040. Is the audio PWMIO, which is what that is playing with. And I'm just treating it like a regular DAC sample. So that the physicality of the speaker will do some smoothing for it. A3, A4, A3, A3. Well, let's see. If I lowered the sample rate, I don't know what zip is doing. Zip could be... I'm channeling R2D2. Yes, I am. I mean, this is the cool thing about Python, right? Is like... Sounds like it would go on an Atari video game. Yeah, it does sound pretty square wavy, but it's not. It shouldn't be a square wave. Oh, you know what? It undid my commented out. Dum dum. Let's speed it up. Hugo asks, are you going to get a DMCA strike for this audio for Skrillex songs? I don't know. Maybe I should start my own band. We could see let's see what it sounds like longer, actually. Yeah, it does sound pretty square wavy still. Eric's laughing at that. Okay, so I know where the problem Steven says sample rate is affecting the pitch. Yes, it is, because our sample is a fixed length. So the length of our sample is based on this this number here, which is different than here. The PWM carrier frequency. Let's just see what logic says. I think it should be plenty. Looks like it's 123 kilohertz is what the carrier is. And that's you can tell when it restarts. The carrier frequency is a function of like 125 megahertz divided by, this is 10 bits. So I'm setting the top value. I'm setting the top value of the PWM to 1023. And then I'm scaling the sample. So either the 8-bit samples or ideally the 16-bit samples, but my math is wrong. Should be giving 10 bits of resolution. My oscilloscope is over there, but you know what I can do is I can, since I have the fancy one, I can actually do an analog capture here as well. It's not going to be oscope quality, but we should be able to see it. Oh, you know it's not plugged in. That would do it. All right, we can take a look at it. I'll switch it over because I'm curious. Where's my ground? I'm surprised I didn't trigger it just by plugging it in. Fancy. Yeah, I know. Okay, here we go. So this is what our signal's looking like. So I think traditionally what you would do, and apparently I have it set up. Traditionally what you would do is you would put like an RC filter, I think, like a resistor and a capacitor on this line to basically take a PWM signal and like smooth it into what looks like an analog signal. I don't know why the scale is so great. So this is at a 50 megasamples per second rate for the analog. So it's still very square in the analog domain. You can see just a little bit of like overshoot, like it's not even really ringing, I don't think, right? Since we have folks here that know what they're talking about, the one thing I've been thinking about, and the Pico can do is, right now what we have is that the PWM is only set to count up and then wrap back around, but it has a mode that would potentially lose a bit, but when it hits the top, it goes back down, and that would mean that the center of the positive pulse would be consistent in like frequency. So does that make sense? Like, should we do that? Is that worth a bit of PWM to be able to ramp up and down and have that consistent thing? I don't know. Pikachu says that's kind of vaguely how a Class D audio amp works. Well, this is a Class D audio amp on here. Mono Class D audio amp. I'm happy with how loud that was. That was good. But yeah, should I switch back to that now that we did the capture? So we can hear it beep and bloop. I should also say that I do have the signal going out on the pin that has the LED on it. I don't know if that would affect sound. Looks to me like you're saturating the input of the amp. So your sines are clipped to square waves. So this capture is not when the amp is connected. Wait, do you mean the timer you're using to output PWM or a counter that's generating the duty cycles? So maybe the datasheet has it explained better. So if we look in the datasheet, PWM, programmer's model. So this is the normal way, where the counter counts up and then you have a top, or you have a capture compare channel, which sets your duty cycle. And then you also have like when it wraps around, which is your carrier. But yeah, here, this is what I'm talking about. This is phase correct mode. So your counter counts up and then it counts back down, which means that your pulses are aligned based on that like middle ground. It's not clear to me, and this is the first I've like listened to it. So like that's one knob we can play with. Yeah, Hamslab says you could put a capacitor and resistor on the signal to smooth the PWM for the scope. Yeah, honestly, that's not my job. Like all the circuitry off of it, like I just need to confirm that like what I think the micro is producing is what we want. So yeah, if folks have, I like I said earlier, like I expect people to refine it later, and like unless you're syncing to someone else on the same timer, it won't affect DC offset or anything. The output PWM will be the same. Yeah, we basically have the timer kind of like to ourselves, so it doesn't matter. Steven says, I feel like phase correct would be more technically correct, but at 100 plus kilohertz, you won't. I don't know if it would really matter. Saltima says, isn't the analog graph you showed scaled up because it's 140 megahertz? I don't know what you mean by scaled up. Yeah, just like... I don't know how to use it. I just use the defaults. Yeah, so let me show you my... Every pulse does not represent 440 hertz. Correct. So every pulse is the carrier wave, which is this 120, 150 kilohertz. And then, so the PWM is running independently. And then what I'm doing is I'm DMAing. I have a separate DMA clock that is running at the sample rate that is just saying like, okay, copy a new one over. And that's when the value of the PWM changes. So they are like, there's two independent clocks happening here. And the DMA will, or the PWM will just keep going. So if you see like, it actually carries over. Oh, I didn't capture anything. But like in this middle ground where the sample's actually stopped, it's actually holding the same value through that stopped period. Because what happens is that if you actually like, if when you stop, you actually like set it to ground, you'll actually cause a click. And so you want to be careful to like, if you pause or stop, you actually preserve the same value. You should also be, and we're lazy about this in CircuitPython, but what you should do is like go to the middle grounds to minimize the pop when you start a new sample. And so theoretically, but you have to take time to do that too, which is annoying. So it's a bit of a trick. So yeah, that's playing with it. And I'll show you my terrible code, which I think is right here. So one of the challenges with what we're seeing is that it has to do conversion. So the sample could be 8-bit, it could be signed, unsigned, it could be 16-bit. And then we're also doing, oh, hey. Hello.
Hello. I don't know if this is working. I don't see you. Do you see me?
Yes, I see you.
Okay.
And you're on the stream. So, surprise guest, everyone. You might not be able to see me because OBS has my camera.
I can't. Yeah, I'm going to open up YouTube in another window because I can't see you or what you're doing.
Yeah, we're doing audio.
Okay.
I might be able to give you cat cam.
Is it done yet?
We were making some beeps.
Beeps.
I think it was.
All right, so you got the wave, like you're just generating a waveform type stuff.
It's just looping. It's looping a sample. So it's just doing like a single sine wave. And I was just showing that off. And I realize I can't see live broadcast.
Right, so I see in YouTube.
Is it done? Of course.
No, this is, yeah.
Oh, you know what I can do? This is what I did with Dan. Now that I think about this. I can pop this window out. There. Now I can watch the Discord chat and talk with you at the same time. I had forgotten that. Your audio.
Okay, cool.
Your audio is.
All right. Well, I don't know what you want to do here.
I think your audio is out of sync. But... Well, thanks for dropping in. I didn't.
Right? I think so too.
I didn't know what we wanted to talk about either, but we could talk RP2040. How do you think it's going so far? Yeah, you're like way delayed.
Well, I do want to try to fix my audio is the only thing because if it's desynced, that's like super annoying.
It is.
Oh no. Hold on. Let me close like everything and refresh. So hold on.
Okay. I don't know if I have to disconnect either. If folks have questions, we'll take questions as well. But Lamore doesn't have an hour, so beware of that.
Okay, what about now? Am I any better?
Yeah, you look better.
Or like the audio, is it?
I think it's better, yeah.
Okay. Okay, well, I could just ramble and then it doesn't matter. How's RP2040? It's good. I think we've got this is an interesting chip. We actually talked a lot about it on the Wednesday show. If people want to they want to afterwards watch the video from Ask Engineer, because we chatted like 15-20 minutes about stuff. I'm always into more competition. More competition is good. Mm-hmm. Is this the end all be all chip? No, like it doesn't. People are like, it doesn't have Wi-Fi, it doesn't have Bluetooth. I think that's okay.
There are good options for both, right?
There are good options. It's not M4. I think that's okay.
Right.
It doesn't have a lot of peripherals that you and I are used to, Scott. Like it only has 4 ADCs, which is like a little anemic.
Right.
There's no DAC. You have to implement, a lot of other stuff. But I think it's cool, right? It's always fun and interesting, and I like when new chips pop up because I think I'm seeing it refreshes people's creativity. I'm seeing a lot of creative projects being built.
Yeah. Yeah, and we've been getting a lot of folks of like, oh, I want to use UART for this, or I want to do that, and it's just like, like I wish we had everything implemented at the start, but it's just like, such a challenge.
Well, considering look, we're still also adding support for the ESP32S2.
Right.
That's not, that's still in progress, and we've only been doing Pico for like 6 weeks. It hasn't actually been that long. It was only like January, pretty much. Like, remember, like in Christmas, we were like, oh yeah, let's do Pico in January.
I think my first commit I looked back was like December 15th or 17th or something. So we had about a month head start. Yeah, and I was good about taking the holidays off. Yeah. I didn't let it absorb me besides the workday. The work days I did. But Saltima says maybe the Raspberry Pi 5 will have it on board. That's fully my expectation. it complements Raspberry Pis so well that I imagine they will. Ugh, your audio is way delayed again.
I think it would also be a good
Dan didn't have this problem. I know yours does this from time to time, doesn't it?
I mean, the only thing is I'm in Firefox. You want me to try Chrome instead? Do you think that makes a difference?
I would try that, yeah.
Okay, hold on. Let me go. I gotta go then log in. So I don't know.
Yeah, we're around.
Talk amongst yourselves.
We could do that. We do have some questions too. Yeah, Firefox. I would totally blame Firefox. I actually have Chrome, and I just pull up Chrome just for when I'm doing video meetings. And I use the actual Discord app, which is based on Chromium, so it's going to have that too. All right, we got some good questions here too. I can try to answer them as well. We don't have to wait for a little more. So Alvaro Fede2 says, why do you think they went with ARM, not RISC-V, lack of software, UK thing? I think it's largely timing. Like RISC-V just in the last couple of years has really grown into its own. And there's just like not a lot of mature designs of hardware. So I think, you know, if you were Raspberry Pi and you were making the first chip you ever made, like I would go with something more tried and true. And like the benefit of RISC-V is that there will be this ecosystem that everybody can use because it's a standard ISA, right? And like ARM already has that. And, you know, there's IP issues to begin with, but like RISC-V kind of, its tooling, RISC-V's tooling hasn't surpassed ARM's tooling yet. So I think ARM makes sense, and I think they also use some like ARM peripherals in it as well.
All right, how about now?
Better, much better.
Okay. There's a reason why I always use Chrome, and I forgot, but I was like, I don't have to like two-factor. So I have two-factor, I'm all good now.
Awesome.
Okay, cool. So
I answered one question about RISC-V versus ARM.
Yes.
Based on my knowledge. David says, hi, Lamore. Arturo has the same RP2040 Zero size, so you both have one and wait for the chip? ?
Yeah, I mean, like, we did an ESP32S2 design. I'm not surprised that other people are doing zeros. I think it's good. You know, mine was kind of like I whipped together one where it would just be the Pico board itself, which is like admittedly a little bit weird,
right.
But I wanted to like, I was, you know, Scott and I were just chatting and we're like, wow, you know, it has exact right number of pins. But yeah, either way, we're all waiting for chips. You know,
right.
I've got the feather design done. We even have the silk screen finished, but I still need, we don't have chips and I don't even know when we're going to get them.
Right. And like I was showing this audio example with the feather because I like the feather more than the Pico.
Yeah.
I feel I have to say it's a prototype, but I am definitely lucky to have that. And I think, you know, Dan and I were talking earlier about CircuitPython priorities, and you know, one thing on my radar is like we have to be prepared for lots of RP2040 boards, and it's just a question of like when people start getting chips.
Yeah, but like we have that set up. One of the things that I really like, and you know, I talked about in the Linux Australia video that I did like 2 weekends ago,
right?
Is that coming from a world with like Arduino where it was basically impossible or nearly impossible to add other boards that were not official Arduinos to the IDE. One of the priorities we had was making it really, really, really easy for people to add new boards to CircuitPython, and it's part of the tooling. Like, okay, so every time somebody does a PR, it takes about an hour to run, but we test every board. And
Thank you, Microsoft.
You know, we distribute. Yeah, I mean, like, did you do math? It's like every time we run, it's like $200.
Is this something we should have a Raspberry Pi story about, or is that something we should keep to ourselves?
No. Let's just talk about how amazing it is that Microsoft, when they bought GitHub, they give people free minutes for open source projects, and because CircuitPython is open source, we basically use like 2 days worth of compute time.
I think you calculated it was a single day for every commit.
It was like a single day's worth. I mean, it's completely parallelized, but you know, it's 15 minutes times like 200 boards times 5 languages.
Yeah, and I think I think with the RP2040 we will hit our 200 board mark. I think that's going to be quite easy once
easily.
people have chips.
Easily. Oh yeah.
That's going to be exciting.
We will have to figure out what are we going to do for PIDs though. Are we going to send them to PID codes? Are we going to maybe Pi Foundation can distribute chips?
Yeah, that was actually came up in the chat earlier today.
Yeah.
I think Alvaro asked and Bruce S was talking about it too. I think we should talk with them about it and kind of get it on their radar.
Yeah, they're gonna have to think about that sooner than later because people are going to expect it, especially since Microchip and Espressif, they'll license a PID for you, which is great. I love that because now all these Espressif boards were like, good Espressif.
Yeah, it's been so nice.
Yeah. Okay, cool.
Yeah.
That's the news. All right, well, I'll hang out for a few more minutes if people have questions, or I'll let you get back to your audio. I think I'm excited to have audio. I'd love to do an audio project.
Yeah.
So that I'm looking forward to that.
It was nice to finally listen to it because yesterday when I was working on it I was just using the Cellier. But I got a Stema speaker hooked up here, and it's fun to actually hear it, right? It's a totally different thing to hear it versus to just see the waveform.
And you've got it's basically doing like a sine wave through PWM, or is it just really just square wave right now?
Right. So what it's doing is so the PWM's running at 120 kilohertz or something, and it's got a top value of 1023, so that's 10 bits, right? So we're DMAing. I'm DMAing at the sample rate to the PWM. So you'll get multiple waves of PWM with the same value, but then the values should change at the sample rate. And it's cool because the RP2040's DMA has pacing timers. So there's timers that are dedicated to spitting to driving DMA.
Oh, so you don't have to share timers with other stuff?
Yeah, it's I have to share it with other DMA.
You have 3 timers. Yeah.
Right.
Well, you have to share it with other DMA, but you don't have to share it with servos or
yeah, totally.
or other tick timers that you're using because we have tick timers for other stuff.
Yep. Yeah.
Okay, that's handy.
Yeah, and it was funny. There was an error. It turned out to be I filed an issue on them, and I was like, hey, your datasheet says there's 4, but the SDK only says there's 2. And I was totally prepared for them to change the datasheet to 2. But instead the SDK was wrong. There's 4 on the chip. So I was like, sweet.
Yay.
That's the right way to go.
2 is just still too little. I always wondered, I never understood that why, microcontrollers have so few timers. I'm always on this, the 7051, I think there's 6 timers. I'm always juggling them.
Right.
Because you need one for every DMA.
Yep.
And so if you have an audio subsystem, that needs at least 1 timer. You have graphics, that's 1 timer. You need 1 timer just for millisecond tick timing.
Right.
And then, some things like servo need a dedicated timer, and piezo have a dedicated. It's amazing. It's okay, then now you're done. That's it. That's all your timers. They go very fast.
Yeah, and that was one of the criticisms I think came out on the RP2040 is that proper timers as labeled in the datasheet is 1. There's one 64-bit timer that we use internally for the timekeeping for CircuitPython. But then there's 8 PWM slices, which are all have divisors from the main clock separately. There's these 4 pacing timers. There's the 8 PIO that all have their own divisors as well. So there's definitely a lot of places that you could get a timer if you needed it.
How is the clocks for the RP2040? I mean, does it have multiple clocks, or is there really 1 clock and you just every peripheral device is off of it?
I think it's more the latter. It's more of just there's really 1 root clock. I haven't taken a huge look at it, and we could pull it up in the data sheet. But the clock tree is not that extensive, and I think that's one of the reasons that their power numbers don't get super low, is because I don't. Yeah. I think peripherals do auto clock gate actually, but I don't remember.
I do know some people have mentioned the power usage is not super awesome. I mean, it's okay. Right. It's I think it gets to under a milliamp, but it's not. There's 2 things it doesn't do, right? There's no code protection, and there's no there's no low power. And what's ironic is those are the two things that I also like. Whenever I release a new thing, I just don't care about those two items.
Right.
People are like,
right,
how do
right.
I like protect the design or the code, or like how do I reduce the power? And I'm like, dude, it just works, right? Like I'm like, give me a little bit of time here while I get it to work. Although I'm
Right.
doing a little bit now that I have that PPK, I'm actually spending a little bit more effort on trying to do low power, especially with the ESP32S2, because it can go quite low. It can go down to like 35 microamps. And if you can go down to 35 microamps, it's like, that's pretty sweet. Like I've got stuff running on a MagTag on my fridge that has been running for a month. Like,
Right.
it does work. It's cool.
Yeah. Yeah, I haven't mentioned this to you yet, but I made a breakout for the PPK2 that takes in micro USB and spits out USB-A so that you can have like measure the USB power from the PPK.
That's good.
And I have a switch on it too, so you can turn the data lines off and on, because you know I love to do that.
That's adorable. You should totally post that on Oshpark or something.
Yeah, it is, and I've been meaning to assemble it because I actually got the boards. But it has this
handy.
it has this USB switch chip that's actually kind of a pain to solder down. So that's part of the reason I've not done it. I've also I got the boards after I was doing done with the power stuff for now. So I think next time I end up doing power stuff, I'll assemble it.
Okay.
But yeah.
Sounds good.
If folks want to link to that, you can bug me on Discord. But yeah, working on audio, and then UART's on the radar. Adding reading from the PIOs on the radar as well.
Do you have enough pins on the RP2040 to get back to your Game Boy thing, or is that you needed like 32 pins in a row or something?
No, I don't. And I was thinking about that. I do want to get there. Like one of the things, and this is why I want to do reading on the PIO, is because like you could just have it slurp in like 16 bits at a time and use it as a logic analyzer sort of thing. So like in the Game Boy case where it's like it works until it doesn't work, like keeping like a circular buffer of what's happening on the Game Boy would be like super handy. So I think I'm hopeful. I'm hopeful we could do that. And I was actually talking with somebody who was wanting to do some other retro computer on the Discord, and they were asking the same thing of like, I want to monitor a 16-bit address bus and an 8-bit data bus and be able to know like what writes to the screen it's doing. That sort of thing. So I think it's super early days still. I think we're going to be able to do stuff like that. I've also been kicking around an idea of like what API we would have in CircuitPython that like builds on top of DMA. So we would be able to like, I called it FIFO. I did a gist that like nobody replied to me about, but like, CircuitPython is really good for connecting stuff up, right? So like, how would you connect one PIO to another without the CPU being involved at all, that sort of thing? And like what API makes sense for that? And I think it's like doing some sort of FIFO thing where you're saying like connect this output FIFO to this input FIFO, and like trying to like patch things together without like ever the CPU being involved. I don't know, thinking about it.
Yeah, it's interesting. So I was thinking a little bit last night about, even though the Pico is only Cortex M0 and it doesn't have hardware floating point,
right?
It could make it's fast enough. And with I2S, it could make for like a cool little like digital synth board.
Oh yeah.
Where
I think so.
You do kind of what the audio library, the PJRC audio library that Paul and another woman, I can't remember her name, worked on for synthesizers, where like you have basically just 512 byte buffers and you just throw them around, right? Like it's just this chunk does a processing on it and it just sends it. And like you have little blocks, and one block might be like invert, and one block might be amplify, and one block might be FFT filter, low pass, high pass, whatever. And then you put them together and you can make little like mini modular.
Yep.
And I thought like, that would be something that could be neat to do. And then in the end, you just pipe it out to the PIO, right? So, I think, you'd have to, I only thought that would be interesting just because it was running fast enough and it was cheap enough. I don't know if it would actually make for a good one, because again, it's an M0 plus, it's not an M4. And I am concerned that like, once you once you do floating point stuff, once you do audio stuff, you really do need floating point, or you're just stuck in like this fixed point hell. But it's something that we talked about, when we did the Trellis M4 of possibly having an audio like subsystem library where you can actually have audio processing blocks. And this would also work well for just data processing too. It's a little bit like ULab, right? You have, I wanted, like issue number 4, it's like the oldest issue we have now, is still like, hey, I'd love to be able to buffer data from the ADC, like say the ADC, go read at 1 kilohertz, and then tell me, like, have a round robin buffer manager and give me chunks of 256 samples or whatever at a time that you've read out, and then I can process them through like ULab or something. This is a common thing that, and it's not even just like, oh, MicroPython can do it or Python can do it. Like, just any interpreted language is not good at this. It's just very bad at it. But like, maybe this is something that we could revisit now that the chips are getting faster. On the M0, it totally didn't make sense. But
on the
anyways, I was
7021,
thinking about it last night.
Yeah, let's think about that more. I've always wanted to do like a synth IO module, right? Like in the same way that I'm using like raw sample, right? Like instead of having raw sample just store a buffer and loop over it, you could have a synth IO module that generates the samples as you're going along. Because there is like that plumbing.
It's basically a FIFO. It's the same thing.
Yeah. Yeah, when I was talking to Dan earlier, I was like, I wish the DMA peripheral would just do a proper FIFO for me, right? Where I just say like, here's a bit of memory, pretend to be a FIFO, and then like let me pull things off the FIFO from that. Like, it'd be really nice if the hardware was doing like the 2-pointer tracking, not just the 1-pointer.
Oh yeah, no, I mean it would be wonderful if it did everything, but it's still, if you're dealing with with audio, right? One of the things I like about audio is that it's only like 20 kilohertz or 44 kilohertz or whatever, and that sounds like a lot, and it is a lot. Don't get me wrong, but it's actually kind of like not that much. Like you can, if you have enough RAM, like RP2040 does, and that's another thing that's really nice, is that you can just have big enough buffers that it's okay if you don't get to it.
Right.
In a few milliseconds, and then you have you have to have a stupid like background task that just swaps pointers constantly,
right?
Or like mem copies. I don't know if there's like a DMA mem copy support in the
DMA is pretty fancy. You can actually the way that I have this looping of the sample working is that there's 2 DMA channels, but the second one is DMAing to the configuration of the first one. Which is kind of
sounds. I mean, it makes sense.
Mind blowing.
Yeah, right. I think that's what the. I mean, I think that when I talked to Eben when he first said he's making this chip, and I was like, oh, there's no DAC, and I was like, oh, it's not a big deal, but like even SAMD21 has a DAC, and it's he's like, what's that for? And I'm like, well, you can do audio, and he says, well, you could probably just do what we do on the Pi Zero, right? Which is the same thing. They have a PWM channel, and they just DMA to the PWM.
Right.
That's how they make audio on the the headphone jack, which is not great, but it's good enough. I don't know.
Right.
We'll find out.
Yeah.
Maybe I should let you get back to that too.
Well, folks who watch my stream know I don't always get that much done on the stream. Although we are having some math problems with our 16-bit numbers right now, so maybe we'll try to do that. But
oh man, there's nothing like audio where you start seeing like the weird like flipped sine waves, and you're like, uh-oh, there's some unsigned signed.
Yeah, that's why right now I have debug code printing out each of the samples to figure out where my math is wrong. So yeah, getting some eyes on that will be good. But yeah, I think there's lots of cool stuff that we can do with it. I think I2S is super easy, right? Like the challenge with PWM is that you're like subdividing time, right? So like getting that 10 bits of resolution.
Well, do you want to do I2S first?
So, remember when I started, I was just going to do PWM, but I refactored it. So like, I'm actually, the DMA side of things is going to be all shared.
Okay.
So,
oh yeah, that's right. You were like, I want to redo this all. And I was like, okay.
Well, I was looking, I originally started with like the I2S code from NRF the PWM stuff from NRF, because that's the only other chip that does PWM audio. But then I looked more into the way that I had done it on SAMD, and I had this, like all of the convert the buffer stuff and manage the DMA things was like factored out between however output you had. So I think I'm expecting it to be pretty easy that like once I figure out this bug with the 16-bit stuff, And then when I try to play a sample that's longer than a single buffer, like once I get all that done, like that should apply across to the I2S just fine. The one tricky thing with I2S is like, how do you do pause, right? You have to like send the same value while you're paused.
Yeah.
And so I'm going to have to craft some PIO instructions to do that, but I think it's doable.
Yeah. No, I'm just thinking like Linux doesn't do that, so you get a pop, and it's very annoying. So
Right.
on Linux, we actually have a little a background task that just cats dev 0 into I2S to keep it from popping when you start and stop playing audio on the
Interesting.
the Raspberry Pi. Yeah, you can look. It's our little hack at the end. It's just like, hey, yeah, this like takes up 10% of your CPU, but like, it's the only way.
At least it doesn't blast your ears.
It's not a blast, but it is like there's a pop. Like
Right.
once you're listening for it, you're like, oh shit, yeah, that's there. But if you
Right.
cat dev 0, it always keeps there's some.
Yep.
It depends on the I2S decoder. Some decoders like they just hate it when you stop clocking them. They just totally spaz out.
Right.
And some are okay with it. So it's like the max 98.765 or whatever. It doesn't like it. So whatever.
Yeah, I was just looking at the one we have in the shop that does the 3-wire I2S. I think it starts with a U.
The UDA 1334.
Yeah.
Unfortunately, that's discontinued, but we still have some.
That's what I've got. Maybe I'll.
No, it's fine. It's a great I2S decoder, and I think I'll be able to get the chips for a while. But it's like it's this awesome like less than $1 I2S decoder chip, and they're like, yeah, so we're not gonna make this anymore. And I'm like, why?
It's too good of a deal.
It's too good. It's too useful. Every chip I like is cursed.
So you've got a new one, right? What's the new one? Do you have a new I2S decoder?
I don't really, but I sort of like the WM8960, which is used on the audio bonnet. And the only reason I kind of like it is, first off, it is really cheap. Mm-hmm. It can do headphone, it can do speaker, but it has this absolutely horrific I2S interface where it's write-only I2S. And so you have to like buffer your entire config, which is like 64 bytes, and then write the whole thing at once.
Right.
And then you have to keep track of what bits you can't read the register back to set a bit. So if you want to set a bit, you have to write like all of the data at once.
Right.
Which is like okay, is like I guess you just have to keep the state.
Yeah.
And you need an M clock, but other than that, it's okay. I mean, none of these are so great.
Yeah, bummer. Yeah, I was just asking in case I needed to pick something up to test with.
The UDA is good. The Max speaker one is fine.
Okay.
Just because it's like you just hook up a speaker and it's good. I do have to go and find another UDA alternative soon, but it's like when chips are discontinued, you still have like 2 years. Like you can still get them for 2 years. It's not like
in it. Yeah.
This isn't like when Starbucks stopped making cake pops and it's like the next day they're like, no cake pops for you. There's lots of warning.
Right. Well, thanks for dropping by. As I told you, you're always welcome. So,
I will try coming by.
I know you're super busy, so whenever you want to, you're welcome.
I was actually just testing the NeoPixels on the PIO. I couldn't replicate it though, so
you couldn't. Yeah, I mean, I trust Jerry to have really good intuition. Like Jerry's usually right, so I'm very curious to see what that problem ends up being, because other people have seen it too. But Jerry was like, has anybody else tried this? And I'm like, well, I have this feather and it has a NeoPixel and it's doing exactly what I expect. Somebody's suggesting I2S stacks for the Great Search on Sunday.
I should. That's a really good idea. I got to find a replacement for this. So maybe I will do that.
Thanks, Eric, for the suggestion.
That's a good suggestion. I'm going to go check in with Melissa and Brent, who, I sent them off into the Home Assistant forest.
Yeah, it looks like they were having fun.
With only half a ham and like a loaf of bread, and I haven't heard from them since. So
I hope they left a trail of crumbs so they could get back out.
I don't know. They're now posting IDF issues, which is kind of a bad scene. All right, see ya. Cool. Thanks everybody. I'll be doing a desk Ladyada on Sunday, so everyone come by.
Yep. Yeah.
By then, maybe I'll do this great search on I2S DAX. Gotta find one for Scott.
Good idea. Yes, please. When everybody's like, oh, I don't have enough like quality, I'm like I2S is the way to go for quality. So cool.
Okay.
Have a great night.
Bye, everybody.
All right. Glad Lavore could make it. Okay, if you did have questions that I didn't get to, feel free to repost them and I'll try to get them. It's a bit juggling the people and the questions all at once. So let me just look back. Eric points out that they've done synth projects with the STM32F0, which is a Cortex M0 at 48. Yeah, these are Cortex M0 pluses at 125, so they should be fine. There's this Interpolator thing that, did I talk about last week? But it could be really wild. I don't think I did. Did I talk about the Interpolator? Somebody let me know. David said, the boss is calling you while you were streaming. What do you do? Well, so you saw me like chatting, like she checked in with me before jumping in. So I'm glad we figured out like exactly how to get it going. I think it was a lot better when she was on Chrome too. Albert says there is FIFO memory. I don't want it to be separate memory though. I want it to be like the DMA and then just RAM. Hamslab says the ESP32 is great for audio since it has floating point. And the IDF supports Bluetooth audio. And Mark's going to take a look at NeoPixel. Oh, Hamslab got Home Assistant hooked up to Adafruit IO. Yeah, Melissa and Brent are taking a look at Home Assistant. Doing some IoT stuff. Love the factory, loves how you showcase the Trinamic having Altium files for the multi-axis closed-loop motion control chip. RP2040 has enough pins to do 2 feathers. Feather seems to have so few pins nowadays. Would you do a dual feather? I don't think so. I would expect like that's really where the Metro comes in, is to get all the pins out. And Pikachu points out that the chip fab is probably the bottleneck. Yeah. Oh yeah, and David says that was a great video, the Australia, Linux Conf Australia talk. If you didn't realize that Lamore did the keynote, it's really, really good, and it talks about CircuitPython before me, which is cool too. Mike asks, has anyone ported Doom to the PIO yet? Not that I know of. I don't know. To some degree, I've seen a lot of these video demos, and I feel like they're valuing the wrong thing for something that is a microcontroller. I think a microcontroller's value is interfacing with other things. And sure, video is one of those other things, but, I'd rather spend my time on UART at this point. More people need that for their stuff. TCD says, were you discussing about 2 different RP2040s communicating via PIO? That's not what I was thinking. What I was talking about more was within the chip being able to using CircuitPython to be able to configure DMA to go from one peripheral to another peripheral without needing CircuitPython intervention on a byte by byte basis. Mark, yes, thank you for reminding me. Actually, let me check in. Thank you. Let's show that off. Where's my browser? So many windows. Let me just open my Twitter off screen in case something bad is on it. Mark reminded me about this earlier. So, Mark says, did you show the X-ray scans on the stream? So there's this that John McMaster did, and we can actually pull this up as well. But they decapped the chip, so you can actually see what it looks like under the hood, which is pretty wild. Let's just pull it up here. So here's what the Pico looks like in an X-ray. And thank you, Mark, for reminding me of that. Let's see. This X-ray shows bond wires easier after removing the thermal slug. I don't know a whole lot. They can see these are the chemicals they use to remove it. Going down, and I can click in here. So this is like, these are the pads that go out to the PCB that you solder in the package. And then there's little tiny wires that go onto the silicon die that connects to the pads. So the things around, actually, I don't know a whole lot about this, but I do have a puzzle. Let's go here. So what you can see here is the things around the outside, they're pads. And we were talking about this a little bit where the internal pads are, like, there needs to be circuitry here to drive the like really big wires on the outside. So they're all on the edge here. And then I think this is a top layer, so you can't see a whole lot. That's where the logo is. But yeah, all these things around the outside are one says, "Were you showing your latest puzzle on the screen?" I don't think it's been long enough. I don't think it's been long enough for me to get another puzzle. I actually have, I can't show it, but Becca, my wife, bought me a puzzle for Christmas that is cat pictures in black and white. So I'm working on that right now. Alvaro, you need a puzzle that says, or a shirt that says, "I don't know much, but I have a puzzle." Yeah, so I would recommend, in fact, I could just post this in the chats. If you're interested in it, check this out. I don't know a whole lot about chip design. But yeah, if you ever want to see what the chip looks like on the inside, I think, where's the link? Like, there's a good discussion about stuff about there, and I don't know as much about it, so check that out if board design is your jam. Yeah, Juan Carlos, hi. I know I replied to you, but I didn't say hi. You did, if you just joined, you did miss Lamore just joined us and chatted a bit because she's not busy enough. She decided to do that too. Yeah, Folknology points out the RP2040 has FIFOs for comms between its internal cores. Did we talk about the Interpolator? So there's this thing. Did I? I think I mentioned it in our CircuitPython meeting. But if you read the features of the chip, summary, it's not in the summary. I thought it was in the summary. Feel like introduction. Oh yeah, so if you look in the introduction, there's this bullet point that says Interpolator and integer divider peripherals. And it was, if you're in Costa Rica, reach out to Fede2, who's doing a workshop on decapping chips. I saw this and I kind of like registered it, but I didn't fully register it. I did not talk. Okay, thank you, Jonah. I got an email from Graham, who works for Raspberry Pi, and said, "Hey, I hear you doing all this audio work. You should really look at and see if the Interpolator can help you with it." So with the Cortex-M0, because it doesn't have as many instructions as like a Cortex-M4, there's some math that can take a lot of cycles to do. And so what they've done is this Interpolator and integer divider thing is some circuitry in the chip that can do certain types of math faster than you could if you just did it on the CPU. And so I saw it here and I was like, oh, that's kind of cool, but I kind of forgot about it, because if you've seen me go through datasheets, I really rely on the table of contents. And the Interpolator, when I went back after Graham emailed me, is a bit hidden. So let's pull it up and let's talk about it. So there's Chapter 2, System Description, Bus Fabric, which is a fascinating read if you want to know how memory works. And I actually ran into an error here. I'll just point it out. There's this narrow I/O register writes. So what I was originally doing with my sound sample stuff is I was DMAing 8 bits at a time. So you could DMA up to 32 bits at a time, but I was trying to just do 8. But what happens is when DMA does just 8 from the original spot, it copies those 8 bits to the other 3 spots in the 32 total bits. So I was writing that to, yeah, Folknology says it's under SIO. Yep, I remember now. Thank you. But there's this weird striping that it does that could be advantageous as long as you know it's going to happen. But when I was doing an 8-bit sample to the capture compare channel for the PWM is actually 16 bits. So what was happening is that the value that I was getting in that register was like higher than it was higher than the actual like value, the top value that I had. So just be aware of that happens on DMA if you're DMAing less than 32 bits at a time. So heads up with that. So under processor subsystem, there's this like 2.3.1 SIO bullet. But if you look at how many pages it is, it goes from page 25 to page 58. So there's a lot of goodness under this SIO section. Even if you read this top bit, you may miss some of these kind of cool niggly things. So this is where you can directly do GPIO. It's the FIFOs there as well, and the hardware spin lock is there too. So you can read a register to tell you what CPU you're on. You can do GPIO control. You can do spin locks. You can do FIFOs like Alvaro was pointing out earlier. But then there's this integer divider. So there is 2 registers, 2 argument registers, dividend and divisor, and it takes 8 cycles, and then the result will be available on the 9th cycle. There's also ready bit in div CSR. So that's one way to do like any sort of division that you need to do. I'll tell you the reason that on PWM I'm deciding to do 10-bit is because you can just shift values to get that. You don't have to do any fancy division. You can just shift bits to divide by powers of 2. So we wouldn't need that in this case, or need this integer divider for that. But then there's this interpolator thing, and it's taking me a while to kind of understand how I could use it, and I'm not using it currently, and I'm in the phase of like I just need to get it working, and if it works, great. What will happen is that there's this process that has to run to convert one buffer type to another, to the output buffer type, and depending on how quickly that can do, it changes how many samples you can get through the system. And so what will happen is that if the code that I write is inefficient now, you'll only be able to play samples that are like a low sample rate. But if we optimize that code, as you optimize that code, you'll be able to play higher fidelity audio because you'll be spending less time. So this is something to look at later. So I haven't used it yet, but there's this kind of chain. So the deal is that it's one cycle to kind of go through this whole pipeline, where you have 3 base registers that I was hoping would go through this chain, but they don't. The base registers get added to the results, and then the results can actually be written, result 0 and result 1 can be written back into these accumulator ones. So yeah, I'm still trying to learn all this stuff, but it's pretty interesting because this works in a single cycle. So if the math that you're trying to do is a right shift and then a mask and then a sine extension, you could do that all in a single cycle, which is pretty wild because if you just took those for individual like ARM instructions, like a right shift, a mask, and a sine extend, like that's 3 instructions. So you're 3 times faster if you're able to use this to do it. And then there's different ways you can do it as well. There's like peak and pop for the results, and that changes whether the result gets fed back into the start. It is one cycle from when you write these registers to when you can read the result. Yeah. Unexpected Maker says, I have new boards coming. I'll do my best to get you over 200. That would be awesome. Luke says it's the Super Mario Kart accelerator. Luke, did you design this part too? I suspect you did. KRS013 says, that's pretty specific. Is this a common peripheral in other microcontrollers? I have not seen it in other microcontrollers. So what I really like about the docs for the RP2040 is that they have this custom stuff, and I'll jump back to that. But they also have stuff that's not custom, and they just straight up tell you that, which is not usually the case. So if we look at like UART here, you can see that it comes exactly from this PrimeCell UART technical reference manual, and you can say it's based on this ARM UART code. So like the UART is explicitly not theirs, and they tell you whose it is. So if we saw it in another chip, like that would make it easier. But then they've taken the time they get back from making another UART, and they put it into these bespoke things like PIO and like this Interpolator stuff, which is really neat. And it's like, that's exactly what you should do, right? Like, you should spend the time on the things that you can add value, not the things that are just redoing stuff. So yeah, this is the Interpolator, and it's meant to just speed up sorts of maths. So like the idea is that you can set the configuration for what math you want to do once, and then you can feed it a bunch of numbers really quickly to do the same thing over and over again. And there's some really feedbacky stuff. Like I haven't wrapped my head fully around this. You can see more details about how a single lane works here. They've got great docs and great examples, obviously. And then there's 2 interpolators per CPU, so there's 4 total. And each of them can work slightly differently. One is in blends mode, and then the other is in clamp mode. So that's why it says like interp 1 is clamp, and interp 0 can do blend. And so they talk about linear interpolation as an example, and simple affine texture mapping, which is way above my head. I've not done that stuff before. But it's a really neat kind of hidden feature, I think, of the RP2040. And these are exactly the sorts of things that you'll see as people use the chip and really learn the ins and outs. We'll learn how to really take advantage of all that. Okay, so we're just about out of time. If there's any other questions, let me know. I'm happy to answer them. Otherwise, let me just show you how terrible my conversion code is in case somebody wants to help me with it. So the way that I'm doing it now, and I extended the way I'm doing it on Sandy, but I'm basically leveraging the compiler to do the conversion for me. And it's super gross, and I'm sure there's a better way to do it, but this is a relatively easy way to read. So this is what is my least favorite part of the RP2040 so far? A kinder way to phrase that is, what are the things I'd like to see changed or improved? I don't know. I did find it a little weird that the real-time clock actually breaks out the individual fields. I prefer a real-time counter. Like, I'd rather just have a counter for seconds or sub-seconds, but that's also because like the internal CircuitPython APIs, I kind of assumed that like everyone's real-time clock was going to be based on a 32K crystal, which is like super common. So 32.768 kilohertz is a magic number crystal wise, and it's used in a lot of like digital watches and stuff because it's like divisible by 2 to the something to get a second. Like it gives you sub-second accuracy, but you can do a power 2 division to get down to seconds. And the crystal on the RP2040 is a 12 megahertz, if I remember right, which is fine, but it's not really like real-time clock crystallese things. Like 12 is picked because USB is 48, so it's easy to get reliable USB from a 12 megahertz clock. It might be 24, but the reasoning still applies. So yeah, that's one, like when I was doing some of the timekeeping stuff, that was a little bit weird. But yeah, like so much of what makes chips difficult is just simply documentation, and they've knocked that out of the park. So like there are things I'm sure they could tell you a long list of stuff that they'd like to improve as well. But for a first go, it's a very impressive chip. Will there be anything new on the Adafruit / CircuitPython PIO ASM front to support all the features? So I think the PIOS ASM library, I think it's complete in terms of parsing stuff out. It's not it's missing some of the like register configuration stuff that is not covered by the like PIO ASM stuff. Yeah, KRS13 is asking if this code's online. Yeah, so generally I use GitHub to back up my code. So if you just follow my, it's kind of hard to find what branch I'm in. I wish they would have a history of what branches you were in. But if you just do tannewt / CircuitPython, it's RP2040 audio PWMIO is where all the backups are. And I should also shout out, there's this video on YouTube. Oh, I'm in the Adafruit account. Oh, I don't want to do that. There's an ARM Innovations YouTube video that the team did with the ARM folks talking all about the chip, and it has like 500 views. So look for that, check it out. It's cool. And there's a cool demo of MicroPython REPL on TV, which is pretty neat. Alra says, what plans do you have for the second core other than the cool debug you talked about? My plan for the second core, I think I really do want to treat it like a PIO. It's kind of what I want to do. I want to make it so that you can control the second core and like load code in and run like really tight assembly code on that second core. I think that's more interesting than running Python on it, honestly. Because we're very much leaning into this like treat Python to do all the hookup stuff and then use time critical for other things. So I think it's way down on my list. Like I probably won't even get to it in this round of stuff. So much can be done with CircuitPython if all the APIs are there, that like I think by the time I do all that, I'm going to be sick of working on the chip and I'll want to move off to something else. So if somebody else adds it, that's great. But I kind of would expect us to leave the second core alone for a while. UART is way more important. Getting the PIO fully supported is important. TG Techie says, would you say the docks are your favorite features so far? I think the PIO in terms of features is like the PIO is very cool. Like NeoPixel was a breeze to do, and I2S looks to be a breeze as well. So like it's kind of a 10-core chip. It's not just a 2-core chip, it's a 10-core chip, and those PIOs are separate cores, because you could make a proper 10-core chip, but then spend one of those like cores that can do a lot more on basic things like what the PIO can do. So I think the PIO is really neat, and that's why I'm kind of leaning into this idea of using the second core that way as well. Hi, Satellite. Hamslab is working on free RTOS for the Pico. That'll be cool. Awesome. KRS13 says, I might take a look. Just put the headers on my Pico too, so I might try out the PWM stuff. Yeah, please do. I'm sure there's bugs, but if you find fixes for the code that I'm not even finished with, that you can still do pull requests to my branch. Yeah, DCD says only assembly. What about relocatable C code? Yeah, that would be totally cool too. Yeah, basically like a binary blob of assembly that you would load from CircuitPython. So user PIO code, do you mean something hard-coded in CircuitPython? I'm not sure what you mean. So in CircuitPython, we're being very careful to have our PIO API allow us to use it internally and use it from the user. So two examples of that are like NeoPixel. NeoPixel actually grabs a state machine just to do the transmit and then releases it again. Whereas like I2S, when you create an I2S output, it will snag a state machine and get it going. So yeah, I think that's about it. We're over time. Yes, that's what I was asking. Perfect. Thank you all so much. I'm glad that Lamar was able to take some time and say hi too. Yeah, and there's Rust on the Pico as well on the RP2040, so that's awesome too. Expect to talk more audio next week. It's not easy code to do, so I've hopefully we'll have a PR by this time next week. And I2S should be relatively straightforward once like there's a lot of DMA testing to do in terms of like doing second buffers and stuff. Like this is kind of a special case that I have working right now. But yeah, give it a shot. Take a look at it. And just a thank you also again to David DCD for doing all the time codes. It's so helpful. And I should thank you for that. How are my YouTube stats? We have 27 likes and 88 concurrent viewers. So likes are always appreciated, but you know, come hang out next week. This has been a deep dive with Scott. It's Fridays at 2 p.m. Pacific. Every Friday. Next week will be Friday. Occasionally it's on Thursday, but next week is on Friday. Take questions. Join our Discord server if you want to chat about any of the stuff that you saw today. You can do that by going to adafru.it/discord. And I realize I should take a look at that. Yeah, and I'll pet spook to end it like I usually do. The other thing I wanted to say, though, is that if you like what you saw, you can support me by supporting Adafruit by going to adafruit.com. I don't think we have any more Picos. I think we sold all the ones we had, and we had a lot. And if you did buy them and it hasn't been shipped yet, we're sorry. There was a snowstorm, and we sold a lot. So sit tight if you're still waiting on it. You know, this is not going away. It's a very cool chip, and we're gonna just see over the next months and years what people can do with it. And DCD says I'm waiting for the Pico Feather too. Yeah, Pico Feather is gonna be great. I'm very lucky to have it in hand. It is very pleasant to work with. And we're excited to see the bare chips for the RP2040 come out and get lots of different board designs doing all sorts of things. So thank you to the Pi folks for making it a cool chip and really pushing the boundaries of what microcontrollers can do. And with that, I'll take my headphones off and pet the cat and see you next week here on Adafruit streams. A couple hours from now, you can also check for time codes and the notes thanks to DCD. All right, have a great weekend. Hi. Did I surprise you? Oh yeah. Chin scratches. Don't start purring though, I'm gonna go. Kitty. Have a good one, everyone.